All right, so 2.1, we're talking about functions. This is totally review of mostly Algebra 1, but a little bit of Algebra 2. So what is a relation? A relation is a correspondence between two sets. Sorry that my writing's a little bit messy in these notes. These are literally meant for me. So it's a correspondence between two sets of data, let's say. A domain, domain is X, which is input, range is Y, which is the output. A function is a type of relation where each X gives no more than one Y. Again, sorry, it's kind of messy. So each X has no more than one Y. So when you're graphing it, you're not going to have two Y's for the same X value, right? X's go this way, Y's go this way. Because if you had two Y's, it wouldn't pass the vertical line test and it wouldn't be a function, okay? An example of a linear function would be y equals 3x plus 2. You have a slope, you have a y-intercept, where x is the independent variable and y is dependent. X is x can be anything, and then y kind of depends on x, basically. Okay, function notation, you can see this written in function notation would be f of x equals, and then that's our y value, so a lot of stuff that we already know, okay? Let's see. So, okay, determine domain and range and whether the relation is a function. So I know you just want to copy this probably, but let's say you have something like this. So for the input, you get this output, input, output, input, output, input, output. So if you have the same output, is that a function? I want you to decide and think about it before realizing, yes, that's okay. Two x's, if you think about an x and a y, two x's can have the same y value. It's still going to pass the vertical line test. That's okay. All right, how about this one? Input, output. So negative 5 goes to 2, 0 goes to 8, 0 goes to 9, 3 goes to 9, 7 goes to 9. Is this a function? No. Why isn't it a function? Is it because of the 0 or is it because of the 9? That's important. It's because of the 0. So no, the 0 can't give you two y values. That means that on the xy axis, at 0, you have 0, 8 and 0, 9, and that wouldn't pass the vertical line test. Okay? Okay, how about something like this? Yes or no? Is that okay? No, the 0, again, gives you two y values, so that doesn't work. Okay, so there's a little bit of review on domain and range. Okay, how about something like this? So, oops, I already showed you. So, determine the domain and range. The domain is basically all real numbers. The range is all real numbers. Is it a function? Yeah, it's a function. This is a line. It has a positive slope. It looks something like this. So, yeah, it passes the vertical line test. Really, this one you're just saying, is it a function? How about these two? Is that a function? Okay, I really want you to think about what that looks like versus what that looks like. So thinking about what this looks like, this is some type of parabola. It has an x and it has a y squared. But because it has a y squared, it's not an up-down parabola, right? That would be an x squared. It's a right-left parabola. Okay, now I'm going to ask you, is it a right parabola or is it a left-facing parabola? I want you to think about it. This is a left-facing parabola. And the reason it's left-facing is because if you had x equals, and then this moved to the other side, it would be a negative y squared. So that would make it a left facing, right? So if you have a negative in front of the squared, it's going to go to the left or it's going to go down. If it's a negative x squared, it goes down. Okay, so what about this? This is a parabola that goes up, down. And does it go up or does it go down? This goes down, because again, if I moved my x squared over to the right side, if I subtracted it from both sides, I'd have y equals negative x squared plus 17. That would be a negative a value in front of my x squared, which is a downward facing parabola. Okay, and then for the second part, it says evaluate. You should be able to do this without looking at my notes, okay? So you're going to evaluate f of 3. Plug in 3, and then check your answer. You should get 22. And then you're going to plug in, and then you're going to do f of x plus f of 3. All right, what's f of x plus f of 3? Do it. Do it for real. Don't be a big cheater. All right, and then you're going to check your answer and you get that. Okay? All right, the next one, what's f of negative x? So you have to plug in negative x and you have to plug in negative x. Do it for real, and then you get that. Okay, the next one, how about negative f of x? Well, that means you just put a negative in front of the whole thing, right? Do it for real. All right, final answer. There's like no work, I know, because you just put a negative in front of each one. Okay, this is it the best one? This is the almost best one. So, plug in x plus 3. Every time you see an x, you plug in x plus 3. You do this in Algebra 2. So do it. Do the first step at least. And then check that first step. So see how instead of an x, it's an x plus 3 squared. Instead of an x, it's an x plus 3. And then right here it says plus 1 equals. And then all I did for the second step is I FOILed this part. So I still have my 3. I FOILed. And then I distributed my negative 2. And then I distribute some more. Oops, like that. And then I get my final answer. Okay? Okay, the last one is the best one. I would call all of these. This is like super easy, super easy, super easy, super easy. This is quite good. I like this one. This is like easy medium. I'll call it medium. How about that? I'll call this medium. The next one is medium hard, and the next one is for sure test worthy. You should tell yourself, look, I told myself that's test worthy. Okay? There's like highlights and stars and everything. Okay, so what does this mean to do? All right, I'm going to take x plus h. I'm going to plug it in everywhere I see an x. And then I'm going to subtract f of x, so minus this whole quantity, and then all over h. All right, you're not going to do this in separate steps because you're not crazy. You're a really good math student. You're going to do this all in one step. You're going to do this minus this all over h. And you're going to write it really nicely, like that. So I see my original function, 3 something squared minus 2 times something plus 1 minus f of x. So this pink one goes with this pink part. This minus f of x is right here. All over h. You do it in one step so you don't forget anything, because I know that we tend to forget stuff. So don't forget anything. All right. Now you start multiplying out the top. So you FOIL and then you distribute the negatives. So I started to do that. So I FOILed, I distributed the negatives. You distribute the 3 some more. There you go. And then I can see what I did right here is I have a plus 1 and a minus 1. Those divided away. And then I started to combine because I realized if I have a 3x squared, it's right here. And then here's my 3x squared. And then some of them I did combine a little bit. I saw my negative 2x and my positive 2x, and then that subtracts away, and that's why it's not here anymore. Okay? All right, I put it all in order. So when I put it all in order, I can see, oh, now I can subtract those away. I'm left with, that's an h on the bottom. It's really messy, but it's an h on the bottom. And then I can see these subtract away. There's an h on the bottom. I can divide away an h from each term, and then I get this. So divide the h, divide an h, divide an h. It has to be from each term. And then my final answer, I can leave it like this. It's okay. The reason I have it like this is because normally if you have an expression, you want to have variables first and then the number, and then your variables normally go in alphabetical order. Okay, so this is not wrong. This is totally fine, but so is this. Okay, this is like a little bit more, you know, traditional, that's all. Okay, but both are fine. All right, on to the next page. Okay, implicit versus explicit functions. So what is implicit? Implicit would be your f is defined by an equation with x and y. So you can see x and y are both on one side. Okay, so your function is x and y both on one side. All right, explicit. That means it's y equals. Everything's in terms of x. So when you're being explicit, you're being very specific about things, and you're saying, I'm going to plug this in, and then I'm going to get a y at the end. So it'd be an equation like that, right? So y equals. These are implicit, these are explicit, these are all explicit, these are all implicit. See how the x, y's are on the same side? See how this is y equals. That's all it really is. Okay. To find the domain, it's been a while. To find the domain of a function, we look at two things. We look under a fraction bar. So if it's a fraction, if I said, what's the domain of this? You would look down here and be like, oh, under a fraction bar, I can't have a 0, right? You can't do 5 divided by 0, that's undefined. So the domain of this is everything except for 5. Or sorry, everything except for 0, because you can't have a 0 on the bottom. I was looking at it, weirded out. Okay, and then also in a radical, in an even radical, if this is a square root, a fourth root, a sixth root, you don't want a negative. Can you have a 0 inside here? Yeah, you can have a 0. The square root of 0, put in your calculator, it equals 0. So no 0 under a fraction bar, no negative inside a radical. That's domain. Okay, that'll tell you what the domain is. So I'm going to give you a couple examples of that. Okay, I want you to think about example 3. It says, find your domain, answer in interval notation. So we did this in class together, that interval notation. So I need you to realize this is a parabola. I need you to see in your head that it's an upward facing parabola. The domain of any parabola, it doesn't have a fraction bar, it doesn't have a radical, it's going to be all real numbers. The way we write all real numbers is not the way you wrote it maybe in Algebra 2. It is not. You write it in interval notation only. You write negative infinity to positive infinity. All real numbers is not an answer. You write it in interval notation. All right? Okay, one more. How about this? Well, you have to look at the bottom of the fraction. So what can't x be? It can't be 1. So if x can't be 1, that means that I start at negative infinity, I go to 1, sorry, this is messy, and then I skip over 1, and then I go to positive infinity. Another way of showing this, just so you see it, is if you had a number line and I said, all the answers work except for 1. So here's 1, and you had an open dot, and then you went all the way to the right, and then you went all the way to the left. This shows you really well how it corresponds with interval notation. You can see it going from negative infinity, and then it skips over the 1, so that's why there's parentheses, they're not brackets, and then it goes to positive infinities. Infinities are always parentheses, because infinities are like not included, right? Infinity is not a real number, so you can't include it, so you can't have brackets. Okay? All right, let's try another. So how about something like this? All right, so you're going to factor the bottom. The bottom, again, cannot equal 0. So what can the bottom not be? It can't be plus or minus 5. What is your answer going to be? So it's everything except for plus or minus 5. Negative infinity to negative 5, skip over. Negative 5 to 5, skip over 5. 5 to positive infinity. I know this seems like a lot of work compared to this, but I need you to know interval notation. You need to know this for calculus, for IB math, for, I forgot what else, but you need to know interval notation, okay? Okay, how about something like this? All right, well, we can have 0. What can't we have is a negative. So I take the inside, and then instead of setting it equal to 0 or not equal to 0, basically, I set it greater or equal to 0. So it can be positive or it can be equal to 0. So I set it greater or equal to 0, and then I solve for t. And then after I solve for t, remember when you divide by a negative, you flip the sign. And then this says that we are to the left of 4/3. So everything on the left side of 4/3 if we were going to draw it on the number line. So it starts with negative infinity, and then it stops at 4/3, but it includes 4/3, so it's equal, right? So it includes it, so it's a bracket right there, okay? Nothing to the right of 4/3. You can't have like a 5 or a 10 or 100, right? You have to stop it at 4/3. Okay, so for the last part, operations of functions, the first part of it is easy, and then the second part, the domain, is kind of tricky, okay? So operations of functions, I'm going to say that part's easy. That's not a problem. When you're adding functions, you literally just add them. When you're subtracting, multiplying, dividing, you're literally just doing that, okay? So when they have those signs, you literally just multiply them, you divide them. When they say divide, put it as a fraction. It makes life much easier, okay? Okay, so here's what you're going to do. So here's the last example. So given f of x and g of x, finds all 4 operations, this one, this one, this one, this one, I think it's A, B, C, D actually, and finds all the domains. Here's why I say 3 domains. You have to find 3 domains. So if you're adding, you have to think about f of x domain, g of x domain, and then you have to think about the domain of the final answer. If you're dividing, you have to think about f of x's domain, g of x's domain, so from here and here, and then you have to think about the domain of the final answer. That's why I say all 3 domains. Highlight that, star it, tell yourself, okay? So the first one, literally, I'm adding, and then when I add those together, I know I did it like in one big step, but basically I said, okay, if I'm going to add these together, what do I have to do? Oh, this I have to multiply by x minus 1 over x minus 1. This I have to multiply by x plus 2 over x plus 2. So I go ahead and multiply the top. On the bottom, I'm being lazy. You can be lazy, but at the end, you have to write it out, okay? So at the top, you're multiplying it out, and then you're adding it together. And then on the bottom, you go ahead and write the actual LCD, which is this one times this one. And then you factor the top if possible. Can you factor this? I tried. I cannot. Because it's not factorable, there's nothing to divide away. There's nothing to cancel. So my final domain, this is my final answer. Okay, this is my answer. But my final domain, I need all 3 domains. X cannot equal 2. X cannot equal 1. Sorry, negative 2. X cannot equal positive 1. And then I look at this one, and the domains happen to be the same as these 2. So I just can't be negative 2, and I can't be 1. Okay. Do the subtraction. Try it yourself. Do the subtraction, and then check your answer. And then realize that you can factor out a negative. So you're going to write it nicely. Factor out a negative. Sorry, this keeps moving. Oh my gosh. Factor out the negative. Because it's really weird to have a negative in a numerator only. So you're going to factor it out to the front. And then this becomes a positive, positive, positive. So the whole negative comes out to the front of the fraction. Okay. What's the domain here? It's going to be the same as this one. I mean, it's pretty straightforward because I already have a negative 2, I have a positive 1 that I can't use, and then those belong to the originals anyway. So I just drew a little arrow. I said the domain is the same. Okay? All right. Multiplication. So multiplication, well, you just like literally, you know, multiply them together. So this times this gives you this. All right, well, that was the easiest one. What about the domain? The domain, I mean, it's the same as these. So the domain, I just drew another arrow. Like, okay, same thing, same domain. All right, the next one is tricky. Ready? So the next one, when you're dividing, it's this over this. So really, it's going to be a fraction divided by a fraction. That means that it's a fraction multiplied by, and then I did LCD over LCD. You can also do multiplied by the reciprocal of the denominator, right? No matter what, you get this. Like, no matter how you do it, you're going to get this. Okay. And then I think about my domain. So my domain originally was, I can't have a negative 2 and I can't have a positive 1. So I have to keep those from my original domain. But now I look at my final answer for division. I can't have a negative 2. Okay, I already had that. And then I can't have a 0. So there's 3 numbers now that I can't have in my domain. So I write that. So I go from negative infinity to negative 2. I skip over the negative 2 just like this. And then I can't have 0. So then I go to 0. I skip over the 0. And then I go to 1, and then I skip over the 1. So some people might ask, well, how come I have to write it like this? How come I can't write? Let's say somebody wants to be like negative infinity to 1, and then 1 to positive infinity. And then I'm just going to switch all the orders, Miss Tan, because whatever. It's fine. You don't know. Okay, I do know. This is why this is no good, and this is the right answer, okay? When you draw a number line, and I'm saying you can't have a negative 2, you can't have a 0, and you can't have a 1. So whole, whole, whole. Everything else is okay. So on a number line, this is my answer, and this makes sense with this answer. See how it goes from negative infinity to negative 2, skip, negative 2 to 0, skip, and then 0 to 1, skip. So see how it matches up that way? See how it doesn't match up this way? You can't see how the one, yeah, it doesn't, you can't do that. Negative infinity is on the very left side, positive infinity is on the very right side. So it has to be written that way. Okay, so there you go. There is notes for 2.1. You're going to make sure that for the homework, you're checking your interval answers for 2.1, and I posted that. So make sure that you're also checking, you check the back of the book, but you're also checking the interval answers that I posted online. Okay, good luck, good luck.